In this video, I'm going over still the differential, solving differential equations by separation of variables, but now getting more into if we had exponential functions that we're solving here. So like for example, notice here we've got our function e with x, divide by y squared. So here we go. Well, what would we do first? Well, if I'm dividing, right, by y squared, then that's why we can multiply by y squared. Same thing here. We're dividing by dx, so I can multiply by dx here. So again, same as before. And then we're going to find the integral here of y squared with respect to y, which is equal to 3 times e to the x with respect to x. So now here I've got y to the third over 3, which is equal to still 3 times e to the x plus c. Now here, notice, same as before, we're dividing by 3, multiply by 3. So that means here y cubed is equal to 9, right, from distributing my 3, e to the x plus c. Then here, cubed root. And because it's an odd function, no plus or minus is needed. Now, this one, however, though, is going to be a little different. So keep that in mind when solving. So here, same as before, we're going to separate. So because we're dividing, right, by our e function here, e to the 2y, we're going to multiply by e to the 2y. So now here, we're going to take the integral of e to the 2y with respect to y, which is equal to the integral of 2x with respect to x. Now notice, we have u substitution here. U is 2y, so our derivative du is equal to 2 times dy. We're going to divide by 2. So notice here, this is 1/2. So we have 1/2 times e to the u with respect to u is equal to still 2x with respect to x. So now here, well, e to the u is still e to the u. So that's why this is 1/2 times, or e to the 2y divided by 2 is equal to x squared plus c. So now here, notice we're going to multiply by 2. And now I've got e to the 2y is equal to 2x squared plus c. Now, how do we solve equations that have e? Well, inverse operation, inverse of e is natural log. So natural log here. So that's where we get, so sorry, I'm going to bring this over, 2y, which is equal to the natural log of everything here. 2x squared plus c, because that was all here, so keep the plus c even inside. Now divide by 2. And y is equal to 1/2 times, or you can leave it as your fraction, the natural log of 2x squared plus c. So here, pause the video and try these two equations on your own. And here we go. So here we've got, we're going to multiply by 3e to the 3y, because that's what's being divided, and multiply by dx. So here, 3e to the 3y dy, which is equal to 5x to the 4th with respect to x. Now, you should have noticed you had to use u substitution. U is equal to 3y. So the derivative here is 3 times dy. Divide by 3. So notice we've got my 1/3, but 1/3 of 3 is 1. So really, we're just going to find the integral of e to the u du, which is equal to the integral of 5x to the 4th with respect to x. And the integral of e to the u is still e to the u, or in this case, e to the 3y, which is equal to x to the 5th plus c. So here we go. We got to solve here, but we've got e. So what's our inverse of e? natural log. So that means here, operations cancel out. I've got 3y, which is equal to the natural log of, remember, this was already over here, x to the 5th plus c. So keep it all together, x to the 5th plus c. And then divide by 3. So y is equal to 1/3, or you can leave it as your fraction here. So now here, same thing, right? We're dividing by 3y squared, so we're going to multiply. So this is the integral of 3y squared, which is equal to the integral of 4e to the 2x with respect to with respect to y. So here we end up with just y cubed, which is equal to, now here you had u substitution. U was 2x, so the derivative here is 2 times dx. Divide by 2. So now we have 1/2. Well, 1/2 of 4 is 2. So I've got 2e to the u with respect to u. So y cubed is equal to 2 times e to the 2x plus c. Now all we have to do here is cubed root. So now here, cubed root of 2e to the 2x plus c. So now the last type. Notice a little different because we're used to solving if it was 4x divided by y. But now notice this is 4x times y. So now to separate the variables, we're going to have to divide by y. Now to show divide by y, that is the same as multiplying by 1 over y. So again, this is 1 over y. So here, and then multiply by dx. So that means here we're going to find the integral of 1 over y with respect to y, and the integral of 4x with respect to x. So now here we go. Well, the integral of 1 over y, what was that? The natural log. The natural log of y is equal to 2x squared plus c. So again, now we're solving for y. So what's the inverse of natural log? E. So now here, canceling out, y is equal to, now again, just like before, this entire expression was already here. So this is y is equal to e to the 2x squared plus c. All of this is in your exponent, and that is the final answer. Now, for those who are wanting to take it a step further, then you could simplify this even more because this is applying our exponent rules. So noticing with the plus c. So like for example, if let's say you had x to the 3rd times x to the 5th. What was this? X to the 8th, right? Because this is x to the 3rd plus 5. So again, notice how adding the exponent is the same as multiplying. So this is the same as e to the 2x squared times e to the c. Now, e to the c, well, is just another constant. So that means here, that's why I could rewrite this as times c, or y is equal to c times e to the 2x squared. So again, here, taking it that step further. So here, again, notice to separate our variable because it's being multiplied by y, we're going to have to divide by y, which is the same as multiplying by 1 over y. So here the integral of 1 over y with respect to y is equal to the integral of 3x squared with respect to x. So now here the integral of 1 over y is the natural log of y, which is equal to x cubed plus c. So here we go. That means here inverse is e, canceling out. Sorry, ran out of space. So y is equal to, remember, this entire expression was already here, so that is your exponent. E to the x cubed plus c. Then for those who want to take it a step further, right, because addition means multiplication here. So y is equal to c times e to the x cubed. So here, let's pause the video. I'm going to go ahead and actually realize we're not going to do this one, and let's just change this to, just to make sure you're good to go with this type of problem. So the 6x squared times y. And here we go. So again, we're going to divide by y, which is the same as 1 over y. So then here I've got the integral of 1 over y with respect to y, which is equal to the integral of 6x squared with respect to x. So then here you end up with the natural log of y, which is equal to 2x cubed plus c. So then opposite is e. So here I'm at y is equal to e to the 2x cubed plus c, or y is equal to c times e to the 2x cubed. So again, just to make sure, same thing, right? Even with our trig function. Notice how secant squared is being multiplied by y. So what are you going to do? Divide. So divide by y, which is finding here our integral, right, of 1 over y with respect to y, and secant squared x with respect to x. So now here, natural log of y, which is equal to secant squared is tangent x plus c. So then here, opposite, inverse, so e canceling out, and y is equal to e to the tangent x plus c, or y is equal to c times e to the tangent x. So pause the video and try this one on your own. And here we go. So again, because you're multiplying by y, divide by y, which is the same as multiply by 1 over y. So now here we're at the integral of 1 over y with respect to y, which is equal to the integral of cosine x with respect to x. So now here, natural log of y, which is equal to sine of x plus c. So then now here, e opposites, y is equal to e to the sine x plus c, which is y is equal to c times e to the sine x exponent.